Now, before I get started, I want to point out that the array.sort method provides a large number of different overloaded versions. And the examples that I'm going to be showing you here demonstrate a number of the different ways in which you can call the sort method. But I can't possibly cover all of the different sorting techniques. So for more information, to really dig deep into the topic, be sure to visit the .NET Framework documentation, as always. Okay, so I've got a sample method here called sortFiles1. This method demonstrates the scenario, the same scenario I'm going to be using for the next few examples. But in this case, the sort fails. So what it does is it creates an array of files, and it uses the directory info object on the LearnNow folder and the getFiles method in order to return an array of file info objects that I populate in this array. Okay, and I'll hover over directory info, and as you can see, it initializes a new instance of this class on the specified path. And then I'm going to use the getFiles method of that object in order to get all of those files. All right, then the code attempts to sort the array, and this is where it's going to fail. And the reason it's going to fail is because the file info class, this is an array of file info objects, doesn't have that interface that allows me to sort directly on it. So I have it within a try block. It's going to throw an exception, and it'll display the error message. Otherwise, if it were able to successfully sort them, I would use the display file info in order to be able to print out all the files. And I'll talk about that shortly. Okay, so I'm going to go ahead and run this. And I'll select sortFiles1, which is H. And there you can see the result of the exception. So it caught the exception and displayed that message. Okay, so that technique isn't going to work. Okay, so next I'm going to talk about this display file info method. This loops through the array of the files that I send it. So I specifically need to pass it an array of file info objects. Okay, so these examples are all using file info objects, so this is a dedicated method for displaying information about those files. Okay, so I also pass in some header text in order to write that out so I can provide information about what that specific example that I'm running is doing. Then it uses for each, loops through all the files in the array, gets access to a file info object, and displays the file name and the size of the file in bytes. Okay, so now let's talk about how we can get those files to sort. One of the ways is by implementing the iComparer interface. This would allow the array.sort method to sort data that doesn't itself implement iComparable. Or you can use it to create multiple sort orders. And you do that by specifying an instance of a class that implements the iComparer interface when you call the sort method. Now, the iComparer interface requires you to provide a method named compare that compares two instances of the same type and returns the same values as we saw earlier when we were working with the iComparable interface. So less than 0, 0, and 1, depending on the relationship between the two objects. Okay, so for example, if you want to be able to sort an array of file info objects, you'll need to create a class that implements iComparer, and then supply an instance of the class when it's time to sort. Okay, so the sample project includes two of those. So the first one is compare file names. So there's the class name. It implements the iComparer interface, and then implements that method. So it has to take two parameters of type object. So then I need to cast those objects to the particular types of objects that I'm working with. And so I'm going to have a file1 and file2, both of file info, cast from X and Y. And in this case, I want to compare the full name. So I want to sort these in alphabetical order by the full name of the file. Okay, so I just used the compare to method of a string. As you can see there, full name is a string. Strings implement compare to, and so we can do that kind of comparison and just immediately return that value. Okay, so that's going to let us compare the file names and sort them in order of the file name, the full file name. And then the second one I have is I want to sort them in order of file size. So this class overall is very similar. So I'm implementing iCompare. I have to implement the compare method. I get file1 and file2. But then here it varies just a little bit. The first thing I want to do is compare the lengths of the files. So as you can see, length is implemented as a long, and a long implements the iComparable interface. And so I'm able to use the compare to method and compare those two values. And I may have misspoken. So this implements, the string implements the iComparable interface, and that's why I can use compare to. If it implemented iComparer, then I'd have to implement the compare method. Okay, all right, so it gets that value. Now, the wrinkle here is that if the files are the same, I want to use the name for sorting. So if I have 5 files in the folder that are all the same size, 50 bytes or whatever the size is, then I want to sort those in name order. And so I check to see if result is 0. Then I go ahead and compare the file names of those 2 files and then return that result. Because it's important to understand that this method is called for every pair of objects that I'm sorting. And so this, what ends up, it's not a bubble sort, but it essentially, the right sort order bubbles up from all these little comparisons that are being made of the 2 files. It's really a pretty slick technique. Okay, so now if I come back over here to program 2, I have this sort files to method that takes advantage of that. So I once again use the getFile methods of the directory info for that folder, and I create an array of those file info objects. And now, in order to use this particular technique, I call array.sort, I pass in the array that I want to sort, and then I pass in an instance of that class that has the logic in it that I want to use to sort the objects. In this case, in this first example, I want to sort them by file name, and so I pass in the compare file names, which is that first class that I showed you. And so this is comparing the file name properties of that object. Okay, so that sorts them in that order, again, by file name, and then uses that display file info method that I talked about in order to display the files. Put in a blank line, and then I want to sort the array by the file lengths. So this time I pass in an instance of the compare file lengths, and then it sorts that based on the logic here, which is first by length, and then if the length is the same, then by file name. And so that sorts the files within my files object, and then I use display file info in order to display them once again. And this time, there should be no exception that's thrown, and so this catch block shouldn't execute. So we'll go ahead and give it a try. And I'll select sort files to, which is I. And there you can see that I have several XML files. So this is sorted by file name. So these are all sorted in alphabetical order by file name. And then this is the second one, sorted by file sizes. So as you can see, 170, 171, 346, 255, and so forth. Okay, so now we're able to successfully sort an array of file info objects, even though file info itself doesn't implement the features we need in order to be able to natively sort an array of those object types. Okay, so that's a solution to our problem. But we can do better. Because you're creating a class when you implement the iComparer interface, you can make the class smarter as well. It seems a little bit silly to require 2 separate classes that do pretty nearly the same thing. You know, it's just a little bit different logic that it's implementing, but overall, the classes look very similar. Why not use, instead, just one class that implements iComparer, but have the class's constructor allow you to indicate the order in which you'd like to support? Okay, and so we have exactly that. So let me open up the compare files class there. And now this is getting a little bit more complex, but it encompasses logic that allows you to specify which compare method you want to use, file names or sizes. Okay, so the first thing the class does is it defines an enumeration. This makes it easy so that you can use a value from this enumeration to specify the order that we want in a particular instance. Now, this isn't necessary, it's not required for the technique, it just makes it easier because then when we instantiate the class, we can specify what the order we want is. So this is going to use that compare field enumerator that'll be passed as part of the constructor. And that just makes it real easy. Makes the interface very easy to use these different classes. Okay, and then we have a public property. So alternatively, we could instantiate the object, set the compare on property, and then pass it to the sort method. Or we could read the value as well. And now notice that if we don't supply a value, then we're going to compare the file names by default, because that's the default setting for that property. And I keep calling this a property. Strictly speaking, it's a public field. Doesn't really matter in this case, but this is really a public field as opposed to a property. Okay, then we have the constructor. Requires you to specify that value. And then finally we have the implementation of compare, which itself is once again a little bit more complex, but it's only because we're including the logic for both comparing the full names as well as the lengths. Okay, so once again, it casts those x and y objects to file1, file2, creates a result variable, sets it equal to 0 for the default, and then it uses that compare on, the value of that public field, in order to determine which logic is used. If it's equal to the enumeration compare field name, then it's going to just compare the full name. Otherwise, if it's length, it's going to implement the logic for comparing the length, and if they're the same, then the file name. And then it returns that result. So overall, what's going on in this method is the same thing. Only thing that's different is that we now have a control in a single class over which method this class is going to use in order to compare objects, and thereby what the sort order is going to be. Okay, and so I have another method here called sortFiles3. Same basic thing, get all the files, call the sort method. But now the wrinkle is that I'm newing up a compare files class. That's the class I just showed you. And I'm passing in this case, I want to sort by name. So I pass in that enumeration. So that's that enum that's defined within the class. And then I display the files. And then to sort them by the field size or the length, then I pass in the length enumeration. It sorts them in that order and once again displays the file. So I'll run this again, but this should show the exact same results as the last time that I ran it. So I want sortFiles3, which is J. And as you can see, I have file names in alphabetical order, and then I have file sizes. Yep, okay, so our new technique of using a unified class works.